Alright, time for another draftphysics.com. Debatephysics also.com. Also, without the also, of course. You're going to quit saying that. Oh, habits are just such a pain in the ass. Anyway, so it's been a while since I made a YouTube video, so I figured I better make one, just so the channel doesn't get moldy or something. Anyway, so the last video was the Feynman video. And it is surprising, okay, that, it has gotten 797 views, 30 thumbs up, and nothing. There's nothing, not one single useful comment. I mean, reasonably civil, rational on the subject, pointing out how Feynman had it right or Feynman had it wrong, or even, acknowledging a single one of the arguments about how Feynman described a fundamental. I mean, this is a critical experiment in the whole foundation of quantum mechanics. All the talk of spooky action, all the talk of superposition, entanglement, all of it stems from this experiment. And it's just amazing that so few people can express any kind of argument defending anything, wave particle wise or energy wise or in any form at all. Just absolutely nothing. So anyway, just showing that for the hell of it. Alright, so the videos I have made on the website since the last YouTube video, there have been a few of them, so we'll play a little bit from each one or something like that. Yeah. I could do a video on, the Simon Dan guy is tacky, okay, in his approach and in his cruddy little ads. But the one who's got even worse is the Action Lab guy. His videos are, he makes lots of them. And now they're just overtly commercials. I mean, he's pretending that, there's some kind of good science, in some product. And it's all overstatement about how marvelous the product is. Yeah, if you pay $600 for a tire, you can probably get a tire to last 30 years if you pay $600 a tire. Okay, but if you want to pay $100 or $50 a tire, yeah, maybe it's not going to last 30 years. I mean, duh. It's just so bad. I could talk about that, but it's not physics, and fuck that. All right. I'm just saying the people who are supposed to be talking about physics and have a passion for science are looking awful corrupt when they do all of these in-person commercials, selling the product using their own face and their own identity. I mean, it's bad enough to have a commercial in your video, but when you're actually doing the commercial for the product, that's really tacky. But, whatever. This is the way people this is how they want their information provided. It's in these tacky, crappy forms. So anyway, I read some brozo comments in this video. So this is the last video I made. So we'll see what I'm saying. Decided on the location. Okay, I probably have to increase that volume. And I'll probably have to decrease this volume. So, little details I have to take care of. Instead, we're going to drop the objects from. Correcting Mythbuster mistakes with angle, heights, velocity, and method. Okay, so I was just reading Brozo's introduction to the video where he's basically saying that somehow the Mythbusters video, because it has an error in it maybe, the whole experiment is somehow you throw it out. So it's not a critical error. It doesn't throw it out. It doesn't change the fact that it provides information regarding what happens to clay when you smack it. So no, you can't do that. You can't pretend you can do that. You have to explain why an experiment doesn't work, and you have to explain why the other parts of the experiment are also not working if you're saying it's not working. You have to defend your claims with some sort of logic and reasoning, and he just doesn't bother with any theory. He has no theory to defend what he supports. He's just like a religious person. He's just doing it based on faith. He doesn't have any personal knowledge. He doesn't have any reasoning. He can't explain to you why evolution isn't true. He just says it isn't. It hurts fast things. All right, these are all facts. Okay, so I've pointed out how this whole idea of them calling work, force times distance, when clearly it's not about distance. In the universe, out in space, distance is forever. There's no such thing as measuring its distance. So it's just stupid. And you don't multiply a force times a velocity. So that doesn't even make sense. It's just mass times a velocity. There's no force. Okay, the work is in a mass moving, and all the forces have mass. So this is another one. You could take this all the way to their argument that somehow they claim photons have no mass. Yet they obviously produce momentum. So how can you produce momentum if you have no mass? So again, it just doesn't make any sense at all. I don't know why people believe it. They've done no experiment to prove a photon doesn't have a mass. There's no experiment proving this. It's just something they say. And these idiots all just believe it because they said it. But it's stupid. 49-degree number from. Alright, so we're arguing about the Mythbusters video has this 49 degrees written down. And the question is, the real angle would be 41 if you measured it from the base. If you measure it from the top, yes, it's 49. But if you measure it from the base, which seems more reasonable, it would be 41. So why did they drop the object from the wrong height? Now, there's no evidence they did do that. There's no proof. So we're just stuck with an argument, based on assumptions and no evidence. So nobody's calculated the velocities of the hammer. Nobody's got any real proof that they did it wrong. And certainly they don't have any reasoning to explain that even if they did it wrong, you'd still expect the clay to be compressed 3 times as much. And it's only compressed twice as much. So even if the error exists, the results aren't consistent with kinetic energy. So kinetic energy is still out of luck. And they just don't care about that fact. Alright, so I did play some of the Brozo video in this Brozo is Evil video. And show his... he went back to doing his dropping round things into clay. And I've already explained how that doesn't work. So this portion... Thing to figure out whether the one from up here wasn't twice as fast. So he's using the wrong angle. So he actually has a video where he's saying Mythbusters are morons, and he commits the same crime of measuring from the wrong, putting the protractor, taking the degree measurement from the wrong place. So he has his bar going above 90 degrees. So he's obviously creating extra degrees that you're not allowed to create. Okay, now 49 and 41 don't add up to 90 anymore. So you're in the wrong location if you're using a percentage of a 90 degrees and then you extend the degrees by another 10 degrees, the percentages will be in different locations. So you're not going to be in the right place again. So he's committing the same kind of mistake that he's ridiculing in others, which, again, so ironic. Alright. So this is where I think he misparaphrases me. He quote mines my videos and has me said things that I didn't say. Like, I love dogs or something when I was saying dogs are a pain in the ass. So he completely perverts somebody's perception. If nobody watched my videos, they would think I actually said the crap he put in my mouth, which I didn't say. So it's the most disgusting, deplorable tactic there is on the internet. I don't know of any channel that's ever been successful using that tactic because it just makes every advocate look like an asshole. So this is the last kind of thing you want to support as a video if you have any integrity at all. If you want to ruin the internet as an information source, if you want to ruin the internet as a rational debating source, this is how you do it, is by supporting people who cheat so egregiously. Disgusting. And again, yeah, so I'm just pointing out, I play my actual clip where I'm actually explaining what the distinction between the size of a photon, the thing we call a photon, and the size of the little bits it's made out of. And yes, the photon is made out of very, very tiny things, but the photon itself is much larger than an electron. Its polarization alone is thousands of atoms across. So it can be well reasoned that photons as objects are not small by comparison to, say, an electron, and that an electron couldn't possibly create one. It would be like a dachshund giving birth to an elephant. It couldn't really happen. Okay, not likely. A blue whale. I mean, you make it even. So this is the funny part, right? He writes in tape, Mythbusters mistake, and he makes exactly the same mistake where he miscalculates the angle. So it's just so ironic. Fact, twice the weight. I've done that experiment. Okay, so yeah, I just keep pointing out how there's absolutely no evidence for kinetic energy. 1/2 mv squared, nothing shows it. Okay, except dropping round balls into clay. Beyond that, there's no experimental evidence. And all the evidence is that basically velocity is weight. So you increase something's velocity, you increase its weight proportionally. So if you double its velocity, you double its weight. That's how it really works. All right, so we'll move on to, so this is the video that I actually made. So I made 3 videos, 3 examples of kinetic energy versus momentum, where I'm making the arguments of why momentum wins. Okay, so in this 3rd example, I used the Mythbusters video as an example of momentum winning. So the cars crush, and they show momentum, no kinetic energy. So they crush cars at 50 miles an hour, 100 miles an hour, and there's no sign of the kinetic energy theory being correct. The 100-mile-an-hour crash does not create 4 times the damage. It only creates twice the damage. Then when they do it with a clay blob, they get exactly the same consistent result. Twice the velocity does not equal 4 times the crushing of the clay. Only twice. So it's a pretty good piece of evidence. All right, and it remains a pretty good piece of evidence. So anyway, play a little clip. Your G-force sensor, where it's actually going to measure the full impact. It's always going to be part of the xylophone. It's going. Okay, so they compared G-force readings between a 50 mile an hour and a 100 mile an hour and got a 3-to-1 ratio. Well, that's because they're completely inaccurate readings. You can't put a G-force meter anywhere in a crushing car and eliminate the fact that the part of the G-force meter is going to move. It's not going to stay in one location and measure the G-forces, the change in its velocity to a complete stop. It's not going to completely stop. It's going to keep moving at a much slower speed. And so the G-forces won't be an accurate description of the actual G-forces that the actual car is enduring, because you're measuring things that are continuing to crush at different rates. So you're never going to get accurate readings. So it's really a useless pretense to say you're measuring the actual G-forces, because you can't do it in a car that's changing its size. There's no place you can put the meter to get the accurate reading, because see, you can see the back of this car lifts up. You can see the back of this car lifts up. Those are 2 different G-forces, the one going this way and the one going that way. Can't measure both of those. To be okay, well, no point in pushing the argument, but it's obviously a very poor piece of evidence. Now this is the good piece of evidence, where they show, oh, half twice, you know, I mean, where they show, it's the wrong way of saying it, 1 and 2. Okay, twice as much damage, twice the speed. Glaring, pointing right to the obvious conclusion, which is, yeah, there's no evidence for kinetic energy, and there clearly is evidence against it. So it's clearly decisively consistent with momentum and decisively inconsistent with kinetic energy. The results speak for themselves, so to speak. Complete validation of momentum being the controlling agent, and complete refutation of any kind of notion that kinetic energy has anything to do with it. That 1/2 mv squared is correct. Momentum, no problem. All right, and then I threw in a little oscillator, okay, with a 3 times the mass object, and they're oscillating back and forth. And I pointed out that it's got to have the same energy. This oscillator creates the same energy going backwards every 4th iteration, well, every second. And so when both objects are moving, it loses energy. When just the one little object is moving and the other object stationary, it somehow has more energy as a system. that can't happen. Okay, that doesn't make any sense. It's very good evidence that kinetic energy can't possibly be a correct understanding, because the oscillator cannot have more energy and then less energy and then more energy and then less energy. All right. So this was just a junk comments video on the website, I assume. So we'll just see what I might have been talking about. And then he's going to have both single mass. All right, so this was, I think, Mindless Marbles. I'm not sure who. Somebody did a video. One of Brozo's little minion morons. And they keep trying to say that there's somehow more inertia. Okay, there's some sort of magical force that shows up that changes what levers do. So levers clearly convert, low pressure over a long distance into high pressure over a short distance. That is, they increase the weight of objects. You put a one mass in a certain location, it'll weigh twice as much, depending on where I put it on the lever. And that you can't tell the difference. You can't tell the difference between the two mass here and the one mass here if you're on this side of the lever and you can't look at it. It's going to be exactly the same weight. And there's nothing else you can feel on this side that's going to tell you it's a one mass out here or it's a two mass here. There's no theory that there's any other information going through the lever than weight, pressure. That's all there is. There's nothing else going through the lever. And no matter which weight is on, the two mass here or the one mass here, it will move exactly the same. And any action I put on this side, the lever moves exactly the same. Whether I have the two mass here or I have the one mass here, the lever will move exactly the same. So there's no theoretical hope for some notion that because I put the one mass further out, I created more energy. I can't create more energy. I can't make the one mass have twice as much energy. Can't do it. Can't be done theoretically. It's nonsensical. So by engineering a kind of goofy experiment with little wing nuts sticking out and other things, right, I just point out how, no, the experiment's not showing anything. It certainly doesn't prove kinetic energy, nowhere even close, and it doesn't even prove what I'm arguing wrong because of obvious defects I point out. Prove the kinetic energy theory is to just run a motor, put a motor on that system, and show it taking 4 times more energy, well, twice as much energy, to rotate the... Right, so I'm just pointing out, really, this is just, again, the same argument. Kinetic energy says you use 4 times as much fuel to go 60 miles an hour as you use to go 30 miles an hour. There's no evidence of that. No one's ever done that experiment and produced those results. It's not a fact. Okay, and they just keep claiming it, but they have no supporting evidence. All right. So this is example 2 of kinetic energy. And I don't offhand remember what example 2 was about, so we'll find out. Spreads in both dimensions. Well, gravity's doing the same thing. All right, so I'm pointing out the gravity argument, basically, that gravity creates friction. That's certainly what it looks like here. And this is obviously a description of the inverse square law, okay? And, how gravity affects rolling objects. All right, I think that's part of this argument. Further than you need to go. So you use a little more fuel, but your miles per gallon will be going up and up and up. So another fact is the faster I launch something, the further I'll go per amount of fuel. So if I want to get a rocket to a certain place in space, I don't lift off at 20 miles an hour and go 20 miles an hour, 20 miles an hour, 20 miles an hour. I'll use an insane amount of fuel. But if I lift off going faster, then I'll get through the space much quicker, my velocity, and that will save me a lot of fuel. So the faster I can get up to a fast velocity, the less energy you'll have to use to launch me. I'll get more miles per gallon. So if you were using a lever just to shoot something up, the faster you can launch it, the further it goes, and the more distance it goes per inch of energy. So the amount of distance you get per energy you put in goes up and up and up. exponentially increases the faster you can create a velocity, the higher your velocity. So it's just showing the fact that it's a lot more work to pick up something and lift it. If I was to lift it 1 foot, if I lift it quickly 1 foot, I use a lot less energy than if I sit here and go really slowly. I end up using a lot more energy. These are, not a complex thing to understand, but yes, they won't accept these as truths. This one got rid of its energy quicker because of its bigger mass. All right. So anyway, so it's basically, I think the friction argument is part of that one. All right. So this one is a draft video on the atom. So I'm just making a description about how the classic, orbiting electron crap is just garbage. Electrons aren't swirling around doing figure eights and doing all kinds of weird, trajectories. All that have to have a perfect speed for any of that to be realistic, and it certainly wouldn't hold atoms together. It's much more sensible to think of atoms as magnetic. That is, the electrons are in fixed locations. They repel each other, and they're attracted to a center, but none of the repelling agents can get closer because they're repelling each other and creating a contrary pressure. So it's like a bunch of magnets being held in positions based on a cross tension. They have an attraction to one element and a repulsion to another element, and they can't go to one without having more of the other. And so they're kept in tension. And that model makes so much more sense. The fact that this arrangement of an electron and 2 protons. All right, so I'm just sort of pointing out that the neutron, does create potential. The idea of a neutron plus a proton, which essentially is what a nucleus is made out of. They're not perfect, especially the heavy elements, they don't have the same number of neutrons as protons. But the idea of combining a proton with a neutron creates an element that creates a lot of interesting function as a charged element. If you even thought of it as just pieces of charge, you can understand that there would be a weird scenario where the thing in the middle doesn't really have access to the external universe in 2 directions, that it can't be affected by any charge. It's essentially in a little Faraday cage in a direction, and that it could move in those directions without ever feeling any resistive force. And so this is an important argument underlying the drag argument. Why electrons and protons experience drag, and why atomic nuclei like helium nuclei does not experience drag. You can throw one of those to the moon and it'll get there, but you can't throw an electron to the moon. Which the 2 objects. All right, so it's just more, it's sort of a technical thing, blah blah blah. So just letting you know what's in the video. Okay. So the next video is make the proof. Okay, so this was sort of a challenge by a comment that, we're all stuck here trying to prove something, and they think a proof is a mathematical equation, so they think they proved the work theorem is correct, with circular mathematics. So they create KE, and then they defend KE with a work equation, and then the work equation defends KE. You get it's circular. The 2 things fix each other, but they're wrong and wrong. So both answers are wrong, and they're just using reciprocal wrong things to do their math. So math isn't a proof unless the math is rigorous and doesn't have any flaws in it. So you can't use math as a proof. Proof is an experiment. Proof is something you can see. Proof isn't some it can be reasoned, but it has to be reasoned out of components that you can be guaranteed to be true, that you can have some certainty are true. And so your axioms, the stuff you put into your equation, must be true. 2 plus 2 must equal 4 if 2 plus 3 is going to equal 5. You have to get one right to get the other right. All right, we'll play a little of this. It's already in a location. Strange. That's the right video? No, we're still in the atom. I gotta hit the gravity button. Where was it? Gravity. Alright, so we'll play a little bit. I'm this way. I'm shooting them straight. And I can have them, 1 millimeter apart. Oh, okay, so it's got a little bit of the Feynman argument in it. So, because Feynman can't realize that the light from two headlights, unless they're bent, just send light 3 meters apart, 2 meters apart. It just goes into space 2 meters apart. It doesn't land at a target, miles apart. The light stays parallel. And so when you do a two-slit experiment and you're shooting light through two slits that are a millimeter apart, it stays a millimeter apart. Yeah. All right. Be a giant whale. That's all that's going to change. It'll be something made out of 1 billion cells or something just made out of 4. And the little tiny thing can go very fast, and the big giant thing doesn't go as fast. So it's just an argument about the conservation of energy, and that clearly matter moves based on the force that interacts with it, and the force is quantizable. There's an amount of it. It has to be spread over the bread. Okay, the force is the butter. You're spreading it on the bread. There's only a little bit of butter if you have a little bit of butter, and there's a lot of butter if there's a lot of butter, and it means how fast the bread's going to go. The bread doesn't go as fast as any piece of butter. It goes as fast as how much coverage there is, how much density of force. As giving magnets properties. And those properties are consequent. Right, so the argument here is that it's all the same force. Magnetism is just gravity being reflected off of a magnet. You're just reflecting the same force that creates gravity. It creates the same force that goes into deficit to create gravity. It's the same force that magnets are reflecting. And they happen to be reflecting it in such a way that other magnets can see the difference. So it's like a good example is I shoot purple light at something and it could bounce back as purple light. That would be a non-magnet. A magnet bounces the light back as red from one end and blue from the other. Now you can see its polarization, and now another magnet could see that polarization, and it could be attracted. The reds could be attracted to the blues, and the blue could be attracted to the red, and obviously it would explain the action of the magnet. The magnet doesn't produce any energy, it just reflects the energy that exists in the universe in such a way that other polarized objects can see the difference. Things don't make gravity, okay, they cause it. Alright, yes, gravity is a syndrome. It's an effect of the absorption, the transition from free energy being converted into energy pushing matter. So when matter absorbs energy to be moved, it degrades the energy. And that degrade in the force, while it's occupied pushing, okay, matter, is a simple explanation for the existence of gravity. Gravity is just the deficit created when force pushes matter. Alright. Fairly simple. Alright, and I guess example 1. Yeah, that should be it. Alright, so this is, I remember it was a velocity linear argument. This is when you bang carts into each other. Happens, okay, gravity makes it stick to the surface. And what happens when it sticks to the surface? Alright, so it's the idea of you drop a weight on and double something's mass. So this is the 10-ton train versus the 5-ton train argument. And so their argument is somehow when you, even though you can place the mass on top of the train in the most graceful manner possible, that is, you engineer it so it's only a tiny bit of distance that it actually falls. So there's a little tiny bit of change, and the train goes from going 10 miles, the 5-ton train's going 10 miles an hour. You drop another 5 tons on it, and it goes exactly it drops in its speed. So it's going 5 tons going 10 miles an hour. You double its mass, it now goes exactly half the speed, 5 miles an hour, and it's now a 10-ton train. Their argument is half the energy was lost. There's no evidence that half the energy was lost. And the simple proof I could make is that if I put a 5-ton train on a lever 2 notches out, and I crash a 10-ton train going 5 miles an hour in close to the other side of the fulcrum, it will shoot a 5-ton train going 10 miles an hour off the other side. So I will make twice as much energy on one side that went in on the other side. The 10-ton train going 5 miles an hour, their theory is it is half the energy. They have no tug of war between the two. They can't show, something with half the mass going twice as fast, crashing into something going 1 mass at 1 velocity, right? Yeah. They can't show this one pushing the other one when they hit. The collision is just going to stay right here because they have equal energy. It's a 50-mile-an-hour car hitting a 50-mile-an-hour car. It's the same thing. 10 tons going 5 miles an hour is exactly the same amount of pressure, weight, as 5 tons going 10 miles an hour. If I weighed them on a scale, they'll push the scale the same amount. If I smash them into a quarterback, it'll have the same effect on the quarterback, right? So I could have a 100-pound guy going 10 miles an hour or a 200-pound guy going 5 miles an hour. They're going to hit the quarterback with the same amount of energy. Just a fact. And just make the lever argument again. Alright, so I just made the lever argument, so I won't do that again. But yeah, it's just too simple. It's too obvious. The right people said it. The right people said, I believe. And so I'm just pointing out the history is just that gross. Certain people said, oh, I believe in Leibnizian theory. And, they had just the scantest, crappiest evidence. And previously, people had made tons of arguments about what a mess this makes out of physics. You can't have 2 theories of energy. So Newton, Descartes, Galileo all believed momentum was energy. And you have this new theory that challenges all of their conclusions, challenges all of their logic, and says all of it was somehow wrong. Somehow they got right predictions, but they had a completely wrong theory of energy. Is that believable? They could have a completely wrong theory of energy, and yet they could make all those accurate predictions. I mean, that's pretty implausible, I think. Okay, so, and just because some fancy pantsers said, well, I like this crystal thing, crystal magic, 1/2 mv squared. And it wasn't even 1/2 mv squared, it was just mv squared back then. It doesn't make any sense. It breaks something as simple as a lever. A lever becomes a free energy device because of this theory. And that was true 300 years ago, and they still haven't responded to that accusation. They still haven't shown how no, levers don't work that way. 300 years ago, they said it takes 4 times more energy to go twice as fast. And in 300 years, we have absolutely no evidence that that's true. No physical evidence. I mean, this is so bad. I just don't know how you people, I don't know, I had no expectation that people were so dishonest and so corrupt that they won't admit the truth when it's so obvious. The scientists are worse than the fanatic religious people. I was able to actually convert a few religious kooks in my life. And it's kind of funny that I can't convert any of these assholes to recognizing that, physics is just a bunch of stories. And some of the stories they got way wrong. They got plus and minus wrong. And they still haven't really admitted it. They haven't even admitted that, well, yeah, it does cause some really stupid physics problems. It sort of breaks Maxwell's equations in the sense that you have a description of reality that's just wrong. That somehow a current goes one way and a voltage goes the other way, when no, that can't be true. Alright, anyway. So, that's been the week and a half or whatever it's been, 2 weeks. So, that's enough of a video and such. So, till the next time, and yeah, just call it an update video. Oakley doke. So this has been a draftphysics.com, debatephysics.com also, but again, nobody will interact on these subjects in any give and take kind of way. They will not answer any of my arguments with anything like a rational, reasonable, civil response. Nothing. Just amazing. Oakley doke. So, till the next time and such.